Hello everyone, welcome back to Alkaline Hydroxide 784, and today for the physics series, I have a problem with pronouncing P's and F's. They end up sounding the same to me. We are covering dynamics, okay, so let's get into it. So as usual, I'll just look at the learning outcomes because honestly, yeah, or just go in whatever flow that makes sense to me. Okay, so dynamics. How fun. So the first thing that you should write in your notes for dynamics is of course the three laws, Newton's laws. The first one is the first one is the one with the object moving in a straight line, right? And the second one is force equals to ma. And then the third one is the opposite and equal action, that kind of thing. Okay, so the first I just said it in a very summarized way. So the Newton's first law states that an object moving wait, I'm not sure where exactly to start. Okay, never mind. Uh yeah. An object an object will continue to move in a straight line or stay stationary unless a net external force is applied to the object. I'm pretty sure I didn't phrase it in the way you're supposed to phrase it, but you get the point. So the point is you have this, let's say you have a ball and it's just sitting there doing nothing. So it's just going to be stationary as long as you don't do anything to it, or the wind doesn't blow it, or nothing else happens to it. Because the forces acting on it are completely balanced in the sense its weight is balanced by the normal force acting on it by maybe the table or whatever surface that is on. And it will only move if you like push it or if the wind blows it or something. I don't know. There's an net external force that applies on it. That's applied to it in the sense. And likewise, if the ball is already moving and is moving with the acceleration of 0, in other words, constant linear velocity. Oh yeah, constant motion, that's what you should write. Yeah. If it's just continually moving in a straight line, as long as you do not push it in some other direction, it will just keep going in a straight line. But of course, in the real world, you see the ball stopping. So what exactly is happening to it? There is a net external force acting on it, which is called air resistance. So, air resistance, friction. There are actually things acting on the ball, so that's why it stops in the real world. But in an ideal world with no friction and no air resistance, the ball could keep rolling and rolling and rolling forever. But and that's how people decided to come up with perpetual energy machines. But obviously the real world constraints prevent them from actually existing. There isn't a real perpetual energy machine because of all these dissipative forces that exist in the world. Okay, interesting, right? You should probably look that up because it's fun. And you can laugh at those people who are trying to make those perpetual machines, or you can pretend to make your own one. I don't know. Anyways, that's not important. The important thing is the Newton's law. Okay. So the second Newton law of motion is force equals to mass times acceleration. Or if you want to look at say it in a more professional way, I don't know, the net force acting on an object is equal to the product of its mass and its acceleration in that direction of the force, that the direction that the force is acting on the object, I guess. So just read your notes and then just copy the phrasing in there. I mean, a lot of the physics definitions, right? I suggest the best way to do this is just memorize them, but at the same time know that they work and understand why they work. But for the definition itself, do memorize the phrasing so that you can just copy it verbatim in your exam and not have to worry about losing marks for that. But at the same time, you must also understand the definition and why the definition is written as such. So yeah, you should do both. Then you can do well in physics. You do both the memorization and the understanding. Yeah. Because if you only memorize, then you can write the definitions very well. Okay, cool. But once you get to the question, you're stumped. You don't understand how to start or where to go in the sense. or if you only understand it well but your definition you always keep missing out words, then you end up losing marks in such an easy part of the paper. Like you could get 3 marks if you write the phrasing correctly. So do learn both. Okay, do it in both ways. Okay, right. So the next part is, well, actually how do I go from here? Yeah, that's the main idea of dynamics. All the 3 Newton's laws of motion. Okay, never mind. Sorry, I just suddenly had this huge gap of silence, so just enjoy the music. Okay, okay, so B is the next part is about inertia. Okay, so imagine you have an object, and of course if you look at Newton's first law of motion, it's not gonna move unless something is some kind of force acts on it, right? I mean net external force, not just any force. Okay. Um in that sense, like the you know uh let's say you put a force on the ball and it will move at a certain speed, and you can look at it based on the mass times acceleration, right? You have your second law. So if you look at both of these laws together, if the mass is higher, then the acceleration will of course be lower in a sense. So in this case, if you look at the idea of inertia, an object with a higher mass will have more inertia, as in more resistance to the force, acting on it, and it will therefore go at a slower speed or with a lesser acceleration, as seen in the second law of motion. So yeah, that's the idea of it. Okay, cool. Uh, and the third point is about weight. Okay, so like the definition of weight is the acceleration the force acting on a object by the gravitational field, like due to the gravitational field. So in a way, your weight is considered as mass times g, and it's not the number you see on the scale, but instead the number times 9.81. Yeah, it's good to know this important piece of information, not only for physics, but to annoy all your friends by telling them this nerd being a nerd. Okay, anyway, that's not the point. Okay, so that's the idea of weight. The weight is the effect of the gravitational field on the mass. I'm sorry, I'm like recording this at 12 a.m. and my mind is like and for some reason I'm miraculously awake enough to actually speak like this, so I don't know. Yeah, that's just basically what it is. There isn't anything else more complicated to look at here. And if you want to really go into the nitty-bitty details of how to get that value of g and all that, you must just look at the topic of gravitation and then you will get the answer. Let's not talk about that now. Okay, so the next one is linear momentum. Okay, so linear momentum is defined as, of course, the product of the mass and the velocity in that direction that you're going in. So the linear momentum and velocity are the same direction. Because you don't remember their vectors, so yeah, direction is important. Okay, so that's just what momentum is defined as, and that's just what people have given a definition for. So just take it as that. Yeah, that's the meaning of momentum. Okay, so why do they have this momentum thing then? Maybe because it's like, I don't know, we have force, which is mass times acceleration. So we need some kind of thing that equals mass times velocity as well. I don't know. This is how it works. Okay, so the next one is impulse. So impulse is basically just the momentum, but over a period of time. Like not really over a period of time, but the net momentum that you get, the net change in momentum. So for this one, you can either, if the force is constant, you can just have a force times the time that the impact on the object lasted for, in the sense. Like for example, if a ball hit the wall and the moment that it hit the wall was 0.01 second, then you can times that by the force that was exerted on the ball by the wall, or vice versa, or whatever, and you can get the impulse acting on the ball, I guess. And if it's something that is more variable, like if you get a curve instead of a straight line in your graph, for that matter, then you can use the integral of the curve, as we all know. Integration, calculus, yay. Yeah, that's basically what impulse is. And then the next one is resultant force, the rate of change of momentum. Okay, finally something more interesting than just definitions. So how do you relate the resultant force to the rate of change of momentum? Basically, the momentum change is caused by the resultant force, right? Logically speaking. If there is no net external force, there wouldn't be a change in velocity and therefore no change in momentum. So the change in momentum is only caused by the resultant force. And in this scenario, you can just put Ft equals the momentum, change in momentum. In other words, impulse. So impulse is equal to change in momentum, which is equal to Ft, or if you're doing the integral in the sense of the graph. So that's the relationship. Actually, it's not much more interesting. It's just a repetition of the previous 2 points. So whatever. Anyways, oh yeah, if you still don't get why Ft is equals to something related to momentum, remember that acceleration times time will give you the change, like the velocity in the sense, if you think about it. Yeah, that's why the force times time will give you a change in momentum. Yeah, that's the logic, that's the reason why. It makes sense. And that's why the integral thing also works, because you integrate acceleration, you get velocity, as in the sense, a change in velocity maybe. Okay, so the next point is about the F equals to ma. You had to solve problems with them. Okay. Of course, it mentions that you must take note of, appreciate that the resultant force and acceleration are always in the same direction. So please remember that these are all vectors. Direction is important here. So for both the momentum and the force, it will be generally in the same, always in the same direction as whatever acceleration or velocity that object is going at. And therefore you should, make some sense. If you should also be aware of what is your reference direction. Like if you say right is positive, then if your force is to the left, you must write it as negative. Or if you put left as a positive, then you can write your force as positive as well, based on your reference direction as well. So please do write that down. Write whether you think right is positive or left is positive before you start. Okay. Okay, next point is the conservation of momentum. Okay, so the principle of conservation of momentum states that uh, the net, wait, yeah, if in a system, if there is no change in net external, like there's no change in overall like force or energy in the sense, then the linear momentum, like the momentum of the objects will be the same in the sense. Or like, sorry, not as in the total momentum of all the objects in the system will be the same no matter what. So that's the logic of the principle of conservation of momentum. And what this means is that your initial momentum, the sum of your momentums is going to be equal to the sum of your final momentums. And for your principle of conservation of momentum, you use it to solve your elastic and inelastic collisions. Yeah, so for perfectly elastic collisions, you can tell that all the energy is transferred, all the force is transferred between one object and another object. So let's say the two balls hitting each other, then the ball that um, let's say, wait, what? My mind is not working. Okay, sorry. Okay, so you have two balls going towards each other, right? So when one ball hits the other ball, the main thing that happens is you can either have a perfectly elastic collision where both the balls will just be bouncing back precisely without any change in the in the overall kinetic energy of the two balls in the sense. So the sum of the kinetic energies are conserved, and with all of the scenarios there is a principle of conservation of momentum. So let's say you have the two balls as M1 and M2 and the V1 and V2. So yeah, so if the two balls then sorry, U1 and U2, and then when they leave they will have V1 and V2. So when you bring this to with the idea of conservation of momentum, your M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2, and therefore your final, you can use this to find your, what's that thing called? There's one thing where you can the okay, yeah, like this is what you get. I forgot the name of that thing. They have a term for it. So it will end up becoming M1 U1 minus M1 V1 is equals to M2 V2 minus M2 U2, and that is the equation that you use for perfectly elastic collisions. So in inelastic collisions, right, you will not have a conservation of the energy and all that stuff. Wait, what? No, you won't have conservation of momentum, but the total energy is still the same. So you can use the sum of the kinetic energies to find out the final energy in a sense, I suppose. And in completely inelastic collisions, you know that both objects will stick together and then travel in the same direction with the same velocity. So using that, you can find out what are the velocities of the object after the collision. And of course, as I mentioned earlier, please do take note of the signs. Let's say you define right as positive, then whatever thing that has a velocity pointing to the right is positive, and whatever is pointing to the left is then negative, and vice versa. So just do take note of the sign as well when you're writing down your answer, like you're working or something for your momentum. Sorry, for this kind of questions, I guess. Okay, so oh yeah, okay. This is what I was talking about. The relative speed of approach equals the relative speed of separation. That's what I forgot. It's literally written here in the learning outcome. Finally. Oh, so the momentum is always conserved, but the kinetic energy will change if it's not elastic. So for the elastic one, you can use both the speed of approach, speed of separation thing, as well as kinetic energy remains the same, like the sum of kinetic energy. But for the other two, you cannot use the kinetic energy one, but you can use conservation of momentum. But don't use the speed of approach and the speed of separation, because um, that one only works for elastic. Yeah. Okay, so mm, yeah, I think that's about it. Okay, so we just go to the yeah, I think that's the last point. I'm sorry for like being completely zoned out to the last 5 minutes of this. I honestly am surprised that I even managed to not be zoned out until this time. So okay, cool. Uh good luck for your exams as usual. It and if you found this video useful despite my zoning out, please press the like button and subscribe. And with that, I would like to say thank you and bye.